Hi, I'm Lindsay, and I'll be sharing with you today the activity Stage Stepping. In this activity, students will be participating in a simulation where they compare population growth rates of a population with a 2-child average family size versus a 3-child average family size. And they find that population grows much faster with higher average family sizes compared to populations with low average family size. This activity is appropriate for middle school students. It has ties to the general sciences and social studies, but we can also bring in math with this lesson, as students will be doing some data interpretation as well as graphing some of these different growth patterns. Now, in order to complete the activity, you'll need access to either a wide set of stairs or a set of bleachers. If you don't have access to either of these things, simply line up 4 rows of chairs and that can work just as well. You'll also need the provided age signs that we have included in the lesson plan. And in addition, the activity requires 45 students. So if you don't have 45 students in your class, you'll have to use some other item. Textbooks can work well if you don't have that many students. Now, before the activity begins, you'll want to take some time to label your stairs or your bleachers. And how you do that is the first step would be labeled with this sign, ages 0 to 19. Students that are standing on that first step would represent people of the ages 0 to 19 in that population. The second step would be labeled with the card 20 to 39, the next 40 to 59, and so on. Before beginning the simulation, explain to students that they will be participating in an activity that will show them how population growth changes based on average family size. Now, they'll be exploring population over 4 generations, and as the activity goes on, every minute that passes will actually represent 20 years in history. So for the first round, we're going to be exploring what happens to population when we have a 2-child average family size. Now, make sure that students understand what the word average means. It does not mean that every family in this population is having 2 children. Some families may be having many more than that, some may be less, but on average as a whole, we have a 2-child family average. So let's begin our first simulation. Now, at the start of the simulation, we'll ask 4 students to stand on that bottom row, representing people of the ages 0 to 19. When our first minute passes, remember we're jumping ahead 20 years in history. So those original 4 students have now entered the ages 20 to 39, which is the age when families typically begin their childbearing years. Now, because we have 4 students, we have the potential to make 2 couples, and each couple will bear 2 children, since we're exploring a 2-child average. So we'll have 4 students stand on the bottom row. As another minute passes, we have now jumped ahead 40 years in history, so our original students are of the ages 40 to 59. Our second group of students have reached their childbearing years, and again we can form 2 couples, both of which are bearing 2 children. So we've added 4 students to that bottom row. After the passage of the 3rd minute, we've seen 60 years go by. Our 4 students who were of the ages 0 to 19 have now entered their childbearing years, the ages of 20 to 39, and they've, like the couples before them, have each had 2 children. So we have 4 students standing on that bottom row for a total of 16 students on our bleachers. Now, in our 4th generation, our 4th minute, we actually have seen that our original students have met their life expectancy. We're going to say that in this population, life expectancy is 80 years old. So our original couples, since they've met that, have taken a seat and everybody has moved up 1 step. If we're thinking about our childbearing couples, they've each had 2 children, and so we've added 4 students again to that bottom row for a total of 16 students on the bleachers all together. So at this point, you'll want to take a minute to debrief with students what they saw in the simulation. Some interesting questions to ask would be, well, what would happen if we continued the simulation for another generation, for 5 generations? Well, there would still be 16 students total on the bleachers. What about 50 generations? There would still be 16 students. So what we're seeing is something called zero population growth, which essentially means our birth rate equals our death rate. So we're adding as many people to the planet or the population as are being taken away. Now, in the world, average family size is actually closer to a 3-child average. To be exact, it's 2.6 children per family. So the next part of this simulation, we're going to see how population growth changes with a 3-child average. So let's begin our simulation. Again, we'll start with 4 students on that bottom step. And after the first minute has passed, those 4 students have reached their childbearing years, and this time each couple is going to bear 3 children. So we'll add 6 students to that bottom row. After the next minute has passed, you can see our original 2 couples, 4 students, are within the ages of 40 to 59. And our 6 students that have now entered their childbearing years can form 3 couples. So each of these 3 couples are going to have 3 children. So that means we'll add 9 students to that bottom row. At this point, we have 19 students total on the bleachers. And after 3 minutes, those 9 students that we just added will move up into their childbearing years, the ages of 20 to 39. Now, those 9 students have the potential to form 4 couples. You'll notice that 1 student does not have a partner, and that's okay. They'll remain uncoupled through the rest of the simulation. Each of our 4 couples will bear 3 children. So at this point, we're going to add 12 students to the bottom bleacher. So we have 12 students representing people of the ages 0 to 19 for a total of 31 people in all. Now, our original group in this next minute will meet their life expectancy, so they'll have a seat and everybody else will move up. So at this point, our 12 students who were just added to the ages of 0 to 19 are going to move up into their reproductive years, and they have the potential to form 6 couples, all of which will have 3 children. So at this point, we're going to add 18 students to the bottom bleacher, and we have a total of 45 students on our bleachers representing our population. Now, after the completion of these 2 simulations, it's a good idea to debrief and compare the 2. In the first simulation, where we were representing a 2-child average, we saw population not changing once we reached a certain point. Essentially, generations were replacing each other, as compared with our 3-child simulation, where we saw population growing exponentially. Now, it's a good idea to keep track of both the number of students on the bleachers and the total number of students as you move along. You can do this simply on chart paper, somewhere where students can see, or keep track in chart form. Now, to bring in some more math to this, you can have students actually making estimates before they start the 3-child simulation of how many people they think will be in this population after 4 generations. After the simulation is complete, of course, you'd want them to compare the actual number to their original estimate and see how close or far away their estimate was. Another way to bring in math is to have students graphing this data that they observed. A good way to do that is through bar graphs. So what we would see, of course, in the 2-child average is those bars staying steady throughout the 4 generations versus a 3-child average where we would see them increasing through time. Another discussion you can have with the class is what would happen if we changed some of the variables in this activity. For example, what if we increased the life expectancy? Or what if people started bearing children earlier, before the age of 20? Well, what we would see in both cases is that we'd end up with a larger population size. We know that when couples start their childbearing years younger, they tend to have more children over the course of their lifetime. And in addition, when we have life expectancy that is higher, we end up with more total people in the population at one time. So both of these variable changes would increase our total population numbers. A great follow-up to this activity is the lesson Family Perspective. In this activity, students have the opportunity to see how family size has changed through the generations in their own families. It also allows them to discuss how family size choices might be made. And that's the activity Stage Stepping. For more information on this lesson and a bunch of other lessons, you can visit our website, www.population.org. Thanks for watching.